Hi, I'm Paul Battaglia, and this is Section 2.4. Students enter Section 2.4 having now completed the definition of the derivative, some basic rules of differentiation, and the product and quotient rule. So they might be thinking, well, how many other rules could there possibly be? And so now we get to the chain rule. Why do we need the chain rule? Well, students are going to need to understand that we have to have a way to handle composite functions. So the essential question you'd like your students to be able to answer is, how do I derive a composite function? What we need right away is for students to understand what it looks like to see a composed function. And I think what we want is we want them to look for maybe four things. Can they recognize that something like the square root of x squared minus 7 is a composed function, and that x squared minus 7 is actually inside another function, the square root function? So what I like to do is I like to put four situations up on the board for students to look out for. Number one, they need to look for a differentiable function raised to a power. Number two, can they see that the angle of a trig function has a differential function within it? Number three, can they look for the exponent in an exponential function as a differentiable function? And finally, can they see that the argument of a logarithmic function contains a differentiable function? These are four major situations that we want students to be able to pick up on. So let me focus on two specific examples in the text, example 11 and example 12. Example 11 does a great job of looking at specifically trig functions raised to powers. So spend some time on that example. Make sure students see that they're going to need to be able to derive the power rule, and then within by deriving the trig function itself, including the angle. Example 12 I really like, and I think you can make even more challenging. Try this. Let k of x equal the composition of f of g of h of x, and ask students if they can find the derivative of k. Now this is going to challenge them because what they had seen up until this point was the composition of two functions. Now they're seeing the composition of three. What I like about that is it gets students to think on that AP level, really stretches them. And what we're looking for is, can they apply that chain rule conceptually now, having nothing but notation? And that's really important. They need to be able to think like that. Here's a nice other challenge that you can use maybe to close the lesson. Give students a table. I'll give you an example. Have them construct a table, let's say with 4 rows. And the only thing in that table on the left-hand side are values of x. Let's say we use -6, 1, 3, 10. Then in the columns of the table, we want them to write f of x, g of x, f prime of x, g prime of x. And what I'm going to ask them to do is this. Let h of x equal f of g of x. Can you fill in the table such that there are answers in the table for h prime of 1 and h prime of 10? It's a challenge. It's very open-ended. And you're going to probably navigate around the classroom and get a lot of blank stares at first. But as a teacher, pull back. Don't jump in and save them. Don't help them. Make them think. Make them try and come up with the correct situation. Because the beauty of it is, there is no one right answer. If you have 20 kids in your class, you could have 20 correct answers. And what a great experience that will be for students to be able to share with each other. Well, how did you do it? How did you look at it? What did you see? That gets the whole class thinking on that higher level. So finally, let's talk about one major mistake that we see a lot, and it's just students' inability to recognize the need for the chain rule. They need to start getting more practice so that they understand when they see a function within a function, that requires the chain rule. And what happens many times is that when students make a mistake, it's because they simply didn't know that they had to derive that quote-unquote inside function. I hope these tips have been helpful. I'm sure you'll find much success in Section 2.4.